Whether in domestic use, industrial use, recreational or medical use, the ideal gas law has become the magical enchantment bringing to life pieces of tech and making the human life better every day. Welcome, ladies and gentlemen, as we are about to embark on an exciting adventure through history, science, and daily life. So yes, fasten your seatbelts and let's dive in. It all started in the 17th century when one curious fellow, Robert Boyle, was busy playing with a pump and a confined gas, and it dawned on him that as he reduced the volume of the gas, the pressure exerted by the gas drastically increased. "I've found it," said Robert Boyle. "I've found it," he repeated. Curiosity will never end. During the 18th century, Jacques Charles was determined to win the Nobel Prize. With this attitude in mind, he imagined that heating a gas would add energy to the gas, making the gas to grow up, what we call to expand. And to his expectation, his experiments turned positive, becoming the second piece in our puzzle, the Charles Law. The 19th century was the aha moment for Mother Earth. One of his own, a chemist known as Amedeo Avogadro, devised a unique theory. He suggested that equal volumes of gases at equal pressure and temperature contain the same number of molecules regardless of the gas's identity. He called this the Avogadro's law, the third piece in our puzzle. During the same century, Rudolf and Emil had gained a lot of interest in gases that they combined these three laws, the Boyle's, the Charles, and the Avogadro's law, just to see what's gonna happen. And that was the birth of the ideal gas law, a law that has revolutionized the world of chemistry and changed how the world operates. So, what is this magical equation? Well, the ideal gas law goes like this. PV is equals to nRT, where P is pressure, V volume, N is the number of moles, and R is the gas constant, whereas T is the temperature of the gas in kelvins. You can think of it like this. When the pressure and volume of a gas increases, the temperature increases too by a factor nR. Consider this example. If you had a cylinder of nitrogen gas at a pressure 1 atmosphere and the volume is 20 liters, well, we all know that the number of moles of nitrogen gas is 14 times 2, that is 28. R being the gas constant, that is 8.206 times 10 raised to negative 2. So plugging these values into the ideal gas law, we can easily find the temperature to be 12.19 kelvins. What about when we increase the pressure to 2 atmosphere and the volume to 20 liters, then N remains 28. Plugging these values into the ideal gas law, it becomes 24.37 kelvins. It is therefore clear that as we increase pressure and volume, the temperature of the gas should increase by a factor nR. You can check out tutorials such as the JG tutor on YouTube or visit Chegg and LibriText to learn more examples and practice questions. My aim today is to tell you how this equation is the center of your life. So let's get started. Number 1. Have you ever seen a hot air balloon soaring majestically in the sky, or at least in the movie Around the World in 80 Days? That's the ideal gas equation in action. When the temperature of the gas is raised, it exerts more pressure on the balloon walls, hence the volume increases, lowering the total density of the gas when compared to the surrounding air. The balloon just lifts. Number 2. How do scuba divers calculate the amount of air needed in the depths of the sea? Well, they use the ideal gas equation, holding to the fact that the pressure changes as they dive deeper into the sea, which may affect the volume of the gas they have in their tanks. And have you seen this cylinder? The ideal gas law was used to determine its material strength and size for the noble task it offers you, which is different from this one and this one. At least you now know. Also, at high and low altitudes, chefs in the kitchen use the ideal gas law to adjust recipes due to changes in the boiling point of water at different pressures. You might have never noticed that one, but yes, it does happen. And one last reminder, whether you are a cyclist, a rider, or a driver, remember to check your tire pressure every time you pass through one climatic region to another. In hot places, a full pumps tire may be a half full pumps at a colder place, which may be risky, and the converse is even riskier. Better safe than sorry. So, Whether you are scuba diving, cycling around the continent, or enjoying a meal in the mountains, remember the magic of the ideal gas equation. It is, however, important to know that for the ideal gas equation to apply to real gas situations, a few modifications have been made, such as the van der Waals equation, to include the unique differences of real gases. Hey, thank you so much for watching. If you found this video engaging, consider subscribing to our channel to get the latest content. Until next time, stay curious.